Welcome to Zaption Tour 8.2, Multiplying and Factoring. There are 5 boxes. The essential understanding here in this lesson is that you can use the distribution property to multiply a monomial by any polynomial. So the distribution property comes up a lot in this section, and I want to make sure that we understand that distribution only happens over addition or subtraction. I'll talk more about that as we move along. So let's get into box number 1 here. This is a very good box. Consider the product 2x times 3x plus 1. So the word product means multiplication, and I have a monomial, which is this thing right here, 2x, and I'm multiplying it by a binomial, which is this thing right here, 3x plus 1. So I want to offer you 3 different methods of looking at this product. So the first method is called the distribution property. So I think we're pretty familiar with this. So if I took 2x and I multiplied it by 3x plus 1, I'm allowed to distribute because there is an addition sign between the 3x and the 1. I am distributing over addition. So if I took 2x and I multiplied it by 3x, that would give me 6x squared. And then if I took 2x and I multiplied it by 1, I would get a positive 2x. So the answer would be 6x squared plus 2x. And many of you have probably seen that method before. Let me show you the box method now. The box method is one of my favorites now, and you're going to see me use it when we're multiplying larger polynomials, such as binomials and trinomials, or especially when we multiply 2 trinomials together. So the box method looks like this. I would take 2x, and then I would multiply it by 3x plus 1, and everywhere there was an addition sign or a subtraction sign, you make a little box. And then all you have to do is multiply the two together. 2x times 3x gives me 6x squared, and then 2x times 1 gives me a positive 2x. And look, there's your answer, 6x squared plus 2x. Now the reason I like the box method so much is because if all the boxes are filled in, I'm guaranteed to not miss any terms. Sometimes students accidentally forget to multiply when they distribute, but in this case it's pretty simple. And then let me offer you a third way of considering this product of 2x and 3x plus 1. It's the area formula. Okay, so if I represented 2 x's as just an x and an x on this side, that represents 2x. And then if I did 3 x's here, I have x and x and x and then the number 1. Okay? So on the left-hand side, I have 2 x's. That's what that means, 2 x's. And then I have 3 x's, x, x, x. There's the 3 x's, and then plus the 1. And then I'm going to split, make these boxes everywhere for it. So look what you get. X times x, since we're multiplying area, so x by x gives you x squared. This is another x squared. This is another x squared, x times x. And finally, x times 1 is x. And then do the same thing on the bottom, right? I'd have x squared, and then another x, right? Well, if you put all your like terms together, you have 1, 2, 3, 4, 5, 6. That gives you 6x squareds, and then plus 2 more x's. So no matter how you cut it or think about it, the distribution method, the box method, or the area method, you get the same answer, and this product is represented 3 different ways. Box number 2 is another example. It says multiply. I'm going to go ahead and use the box method since that one's just my favorite. So I have a negative x cubed, and I'm going to multiply this all by 9x to the 4th minus 2x to the 3rd, and then plus 7. And then I split my boxes up accordingly. Okay, here we go. So negative x to the 3rd multiplied by 9x to the 4th is going to give me negative 9x to the 7th. Remember, when we multiply with the same bases, we add their exponents. Negative x to the 3rd multiplied by a negative 2x to the 3rd will give me a positive 2x to the 6th. And then negative x to the 3rd multiplied by 7 would give me negative 7x to the 3rd. And then we would finish the problem up by writing it in standard form. Not San Francisco, but standard form, meaning that all of our exponents, our largest exponent leads, and then we write it in descending order. It already is in standard form, minus 7x to the 3rd, but I just wanted to point it out to you. Okay, box number 3 is all about factoring. I really want to make sure that we understand that when we say the word factoring, we are talking about reversing the multiplication process. So I'll say it again for you. Factoring a polynomial reverses the multiplication process. And the way that we do it is by finding the GCF, or the greatest common factor. So I know you've had some experience with this, so let's take a look at this example. It says, find the greatest common factor of 5x to the third plus 25x squared plus 45x. Well, the way that you do it, or the way that I do it, is I look at the numbers first. I look at 5, 25, and 45, and I ask myself, what's the biggest number I can pull out of each of those, right? Well, I can pull a 5 from a 5, I can pull a 5 from a 25, and I can pull a 5 from a 45. When I say pull a 5 from, it means that there's an equal amount of 5s in there, right? There's not like a half amount of 5s in there. So 5 goes into 5 once, for example, 5 goes into 25 5 times, and then 5 goes into 45 9 times. So I can definitely pull out a 5 from each one of those. Then I focus my attention on the variables. I have x to the third, I have x squareds, and I have an x. And I ask myself just the same question. What's the most I can pull out of each one equally? Well, I can pull x to the third means x times x times x. X squared means x times x, and then x just means an x. So all three of them share at least one x, right? So therefore I can pull out an x from my variables. Now, what does that leave me with? This is where we reverse the multiplication process. If I take a 5x out of 5x cubed, basically what I'm doing is I'm taking 5x cubed and I'm dividing out 5x's. Notice the 5's cancel. 3 minus 1, that division property just leaves me with an x squared. So this leaves me with an x squared. That is the reverse of multiplication right there. That's what we mean by that. Okay, then I have a positive. If I take 25x squared and I factor out a 5x, so just do this for you. 25x squared, factor out a 5x. It's the same thing as dividing out 5x's. 25 divided by 5 is 5. X squared over x is just x, so I'd have a positive 5x. That's where that comes from. And then similarly, if I took the 45x, I would have just a positive 9, right? Because 45x divided by 5x is just 9. So now, here, you can always check to see if you did it right if by distributing. Is 5x times x squared a 5x cubed? Yes, it is. Is 5x times a 5x positive 25x squared? Yes, it is. And is 5x times 9 45x? Well, yes, it is. And therefore, we did it right. And this is what we mean to factor a polynomial. So I want you guys to try this one right now. What is the GCF of 3x to the fourth minus 9x squared minus 12x? All you have to do is find the GCF, everybody. Box number 4 is another example. It says, what is the factored form of the polynomial 4x to the fifth minus 24x to the third plus 8x? So again, look at your numbers first. 4, 24, and 8. What's the most you can pull out of each one? Well, you can definitely pull a 4 out. Then I have x to the fifth, I have x to the third, and I have an x, so I can pull an x out of each of them equally. Now sometimes I use brackets, everybody. That doesn't mean anything different. It's the same as a parenthesis. Okay? So if I take 4x to the fifth and I divide out of 4x, I'm left with just x to the fourth. Minus, this is going to be 6x squared, and then finally plus the number 2. And then I'll do a quick check just to make sure. What's 4x times x to the fourth? Well, that would be 4x to the fifth. No problem. 4x times a negative 6x squared, negative 24x to the third. Yep, that's right there. And that's right there. And then finally, 4x times a 2 gives me a positive 8x. And yep, that's right there. So this is the factored form of the polynomial. 4x multiplied by x to the fourth minus 6x squared plus 2. Okay, and box number 5 is a you try. Part A wants you to multiply x plus 3 times 2x. And you guys, don't worry that the 2x is on the right-hand side. It doesn't matter. It's the same thing as doing 2x times an x plus 3, in case some of you were wondering, okay? It's the same thing. That's why I did this one on purpose for you. And then part B says factor this whole entire thing. So factor the GCF and then get the product left over, okay? Hopefully you got the right answer, but if not, here's the solution. When you multiply 2x by x plus 3, you end up with 2x squared plus 6x. And when you factor out 14x to the third minus 2x squared plus 8x, the greatest common factor is 2x, and you're left with 7x squared minus x plus 4.